Energy is everything. It never dies. It evolves, transforms, and is unstoppable. And it's the energy of 10,000 courageous human beings that brings us all together. People from different cultures with vast skill sets, brilliant know-how, gritty determination, and sometimes a little mischief. So, let's use our combined energy to create smarter ways to help our partners grow, unimaginable potential for the ambitious to spark that glint in their eye for adventure, and groundbreaking ideas to treat our world with a little more respect. Together, we're bringing a whole new energy to an industry ready for change, where hard work matters and where possibilities are created for everyone, everywhere we go. Welcome to the fantastic future of our proud past. Welcome to Kent. Join us, challenge us, get some of our new energy, and discover where it could take you. Kent, the energy within.
Good morning, good afternoon, everyone. My name is Wassim Ghadban. I'm the Vice President of Digital Engineering and Global Innovation at Kent. Today, I will introduce the concept of 8D Digital Tween and discuss the 3 key elements required to achieve predictive operation across the asset life cycle to help operators realize better business outcomes. A little bit about Kent. We are integrating a portfolio of industry leadership and expertise. Within Kent, we have professional engineers and digital innovators delivering excellence every day with the heritage of the industry leading brands. So we have Legacy Kentech, Legacy SNC Lavalin Oil and Gas, Legacy Atkins Oil and Gas, Kent's, and offshore, Houston Offshore Engineering. Kent is a fresh, new integrated energy player who design, builds, and maintain the assets that power the world for today and makes it future ready for tomorrow. Little bit about our services. We are providing advisory services, digital engineering, traditional engineering, projects, completion and commissioning, operations, and maintenance. With projects executed in more than 80 countries, our ambition is to become the global leader in integrating energy services driven by sustainability and innovation. So our innovative digital solutions cover the full life cycle of your asset, from planning, design, construction, and operation. We are pioneers in the digital twin, and we help our clients to plan and design properly the implementation of digital twin for all the phases of the life cycle, starting from engineering, construction, the smart construction, what we call EPC 4.0, and operation to reach the predictive analytics that we are going to describe today. Talking about our credentials, we have delivered many projects in all industries, not only in oil and gas, but we are pioneers in the energy industry to transform our innovative solutions to a value, to unlock the real value of digital technologies in this industry. This year, we delivered the most advanced digital center for ADNOC IWC, which is the advanced version of Panorama. It's based actually on digital twin, and we have implemented many technologies as well, virtual flow meter, geofencing, and the looking glass for training. So let's take a step back. And what is the real value of digital twin, right? So if you could show your management that you can reduce the unplanned shutdowns by 75%, cut the duration of planned turnaround by 50%, and extend asset life cycle by 10%. In many presentations, we have all heard about digital twin can provide visibility during engineering and construction phases of the project, but how do we harness that data to achieve the desired results in the operations? So looking at the challenges of the industry, the energy industry, right? We always hear the same questions. Where to find information? What is the progress of the project? Is it accurate? I don't have access. I was not aware. In which system? Why it's down? I'm getting bad values. What if? What happened? So all these questions are driven actually from the challenges that we are facing today. The lack of integration of systems, lack of sharing the information, having like data not mature, and the quality of data mainly, and also the roles not defined properly by different stakeholders. So in oil and gas, we know the digital twin will drive the Industry 4.0 initiatives and unlock the next wave of innovation. Digital twin is coming under the spotlight as a significant driver of business value and to overcome the current challenges that I just described. There are various definitions, concepts, and platforms for digital twin in the market. But at least the good thing is that goals are always the same. We want all of us to reduce cost. We want to enhance safety. We want to optimize operations. We want to increase production and reduce downtime and definitely reduce emissions. Probably what was not clear to many operators is the reward of digital twin in the life cycle of oil and gas fields. So what is helping us these days more than ever are the advanced technologies to capture more data and analyze them to move toward digital assets. Talking about IoT devices, AI cameras, high power computing, machine learning, data sets, 5G, robots, satellites, and drones. What is to unlock this value, right? The real value of digital twin solution, we need to have like a roadmap, right? So to reduce cost and enhance safety, but how to achieve this roadmap? So digital twin is like moving from static information to real-time information. So it's about the connection between the physical asset and physical environment and digital environment. And this is what we call maturity levels. Like we have single way of integration and we have full integration and synchronized between the two environments. So a feasible approach will be to look at digital twin as a roadmap, which can increase financial benefits throughout its evolution. The digital twin roadmap must focus on creating business value at every step through better integration across various technical disciplines, organizational function, and key players in the value chain. Well, what is the framework then? So digital twin, again, is an ecosystem of asset life cycle where data gets read and matured as we move forward toward operations phase. It's an ecosystem of asset information, tasks, process simulated and displayed in digital context for an integrated project execution and unified and predictive operations. To be noted that all project stakeholders and operations team to contribute in the development of this ecosystem. It's like a Google map built and consumed by all of us, talking about the traffic data and documents and information that we publish. So we really need to take the concept of digital twin as layers. We start by the 3D model, which is very important for us in energy sector, which is the foundation of digital twin. I know other industries, they don't care about 3D model. They just maybe focus on dashboards, but for us it's really important. So the engineering data increase as feed proceed. Data are increased as engineering activities proceed. Engineering data are updated to reflect as build status. Real-time operation and maintenance data are integrated in the digital twin. Engineering data maintained as operated. Live streaming is a layer to monitor operations data. Operational historical data will provide analysis and insights and can be used for unmanned and autonomous operations. So this progressive approach starts by collecting data and integrating system of different phases. So usually what we do, we integrate all the systems for engineering, talk about DCS, the systems for planning, P6, system for design, whether it's 2D design and 3D model. And during construction, we integrate with progress measurement tools to have the 4D, 5D. We integrate with safety tools as well. And during operation, this is where we start the integration with real-time systems. Talking about the DCS, the historian, the LIMS, and the GIS to achieve this ecosystem. And the digital twin at the end is the brain of data to control all this data integrated and in an integrated approach, having this integration between all the systems. So it's the system of systems to be able to achieve our goals. And that will lead us to the definition and the concept of 8D digital twin, right? It's not BEAM, it's more specific for energy industry and drilled down to equipment level. So for each equipment, if we consider, for instance, a pump, right, AD Digital Twin will provide a remote operators, AI autonomous model with all data captured during the project lifecycle by different systems and tools in different timelines. So if we look at the pump, what are the information that we are talking about? The 8 dimensions. So all engineering specifications, data sheets, PNIDs, PFDs, 3D model, point cloud, GIS coordinates, cost information, risk data, installation and maintenance schedule, real-time operational data, pressure, temperature, vibration, spare parts available in the warehouse, work orders, permits, live streaming from satellite or CCTV, and the dynamic machine learning model, which is a portfolio. We call it dynamic predictive portfolio for each equipment. So the important part is this is a single source of truth that will reduce downtime, optimize operation, and will make the right information available at the right time to the right team to take better decisions. So, for instance, if you look at how the digital twin platform, in all platforms, you have the same. You can see, visualize the equipment. You can see the information in their context. You can see the faceplate of each equipment, right, with real-time information. And then you can see the information captured from engineering and construction phases as well. So you have all data from different tools, the tools and systems that we highlighted, the integrated tools with digital twin. And then you will be able also to walk through inside the digital twin, visualize your information based on your queries, and you can like group them by systems based on your needs. So it's very important always to differentiate between the digital twin and digital twin experience. So digital twin experience is about how you consume this data, the data from digital twin. So after you build your digital twin, you can visualize this data, consume this data, whether you are using a desktop, you are using a tablet, you are using like a video wall. This is what we see in the digital center, like in Panorama or Dahran or IWC projects that we delivered. Or you can use also immersive technologies. You can use HoloLens, for instance, to overlay the physical equipment outside by the digital information, or the VR for training and simulation. So all of these are considered as the experience, digital twin experience, the ways that we display the information of digital twin. The biggest mistake really I see these days is to consider digital twin as one solution fits all purpose. It's been said that the digital twin is a replica of physical asset, but please don't wait till the physical asset is built to have a digital twin, as values cover like project and operations of asset. So project, we call it EPC 4.0, and the operation is OM 4.0. And as you see here, the digital twin has a role to play virtually in every step of the asset lifecycle, from immersive and automated design in the design phase to informing the supply chain in the operations phase. So for project, it's about optimizing engineering activities by automation, immersive design review, data-centric and unified engineering, progressive handover, the 5D, 4D, 5D, smart construction. It's about safety enhancement, about real-time progress. So you can display the progress of your construction in 4D, 5D, as well in digital twin. In operation, is more about asset performance management and supply chain, connected workers, predictive and prescriptive analysis, integrity management, immersive training. And the list goes on as we move toward digital assets, and that will contribute to our vision about achieving a global ecosystem where everything is synchronized and integrated. Thank you.